Welcome to the DIY Honda Garage channel. The DTC P26E6, specifically identified as the Starter Cut Relay 2 Control Circuit High Voltage, addresses an issue primarily involving the Honda Accord models from 2023 onwards. This diagnostic trouble code emerges when the Powertrain Control Module, PCM, detects high voltage signals from the Starter Cut Relay 2 during engine start attempts. The starter cut relay plays a critical role in preventing the starter from engaging when certain conditions are not met, thus protecting the vehicle's electrical systems and preventing potential damage. The PCM, which is the brain of the vehicle's engine management system, constantly monitors various component signals to ensure that everything operates as intended. In this scenario, an abnormal signal leads to immediate action, such as storing the DTC for further analysis. Understanding this code is crucial for maintaining optimal engine performance and reliability. The error associated with DTC P26E6 relates to the Starter Cut Relay 2, which is integral in managing the connection between the ignition system and the starter motor. The relay is designed to prevent the starter from operating under inappropriate conditions, thus ensuring safety and preventing electrical overload. Located in proximity to the Powertrain Control Module, PCM, the relay communicates critical signals about the vehicle's operation status. If a high voltage signal is detected by the PCM when the starter is engaged, it indicates that something may be wrong within the control circuitry. The PCM evaluates these signals constantly, ensuring that all components of the starting system function as they should. Failure to address this issue may lead to starting problems, ultimately resulting in vehicle reliability issues. The causes related to DTC P26E6 can typically be broken down into a few major categories. A shorted wire in the circuit, particularly the connection between the starter cut relay and the PCM, can lead to inaccuracies in signal transmission. This could occur due to damaged insulation or frayed wiring, which can occasionally happen from environmental factors or wear over time. Additionally, if the PCM itself is malfunctioning, it may misinterpret or improperly signal the relay, resulting in the high voltage error. Connection issues can also arise if terminals are corroded or loose, leading to poor electrical contact. In some cases, the relay may simply fail due to internal faults or damage, resulting in high voltage readings where there should be none. Identifying the exact cause is crucial for effective troubleshooting and repair. When DTC P26E6 is triggered, several symptoms may manifest, indicating a possible issue with the starting system. One of the most apparent symptoms is the engine's failure to start, which could be due to the starter cut relay preventing ignition. Drivers might also notice strange electrical behaviors, such as unexpected warning lights on the dashboard that signal underlying issues in the starting circuitry. Intermittent starting problems can occur, leading to a frustrating experience where the engine may start on some occasions but fail at others. Additionally, if the relay is malfunctioning, it may produce unusual noises during attempts to start the engine, serving as a further warning that intervention is necessary. Recognizing these symptoms early can help in addressing the DTC effectively. The first step in troubleshooting DTC P26E6 involves attempting to start the engine. This process helps to verify the initial conditions of the vehicle and assess whether the starter cut relay is functioning correctly. As the key is turned, both the driver and technician should pay close attention to any unusual sounds or behaviors, such as the engine not cranking or making click noises, which signal potential relay or circuit issues. Recording any immediate symptoms observed during this attempt allows technicians to better diagnose the underlying problems. It is essential also to consider how previous electrical issues may have led to this DTC being generated. Careful observation during this step is crucial for accurate diagnosis. In the second step of troubleshooting, the next procedure requires you to disconnect the PCM connector to prevent any electrical interference during diagnostic testing. Before doing so, using the Honda Diagnostic System, HDS, you will need to jump the SCS line, which is a special connector used for shorting circuits to facilitate accurate diagnostics. This step is significant because it ensures that you are not receiving erroneous signals from the PCM that could mislead the troubleshooting process. The waiting period of more than 1 minute allows the vehicle's diagnostic system to reset, eliminating any temporary fault codes that may have been triggered. After this step, you will be prepared for further inspection of the connecting circuits to identify any issues directly related to the starter cut relay. The third troubleshooting step consists of an inspection of the relay circuit board. This is critical because any issues present on this board could directly impact the functionality of the starter cut relay. During this inspection, focus on checking all wiring connections for signs of damage, corrosion, or looseness, as these can lead to poor electrical contact or short circuits. Additionally, verifying the integrity of the wires connected to the relay can uncover potential issues such as abrasion or internal breaks that might be overlooked initially. These checks should follow the guidance of the open, shorted wire inspection process as outlined in the diagnostic guidelines. Ensuring that these connections are reliable is fundamental for restoring proper operation. In the fourth step of the troubleshooting process, you will need to perform a shorted circuit test. This test allows technicians to confirm whether the ST-cut RLY2CL circuit is shorted to power, as indicated by the initial DTC. Utilizing the HDS diagnostic tool to check the connections and signals further assists in validating the operational condition of the starter cut relay. It's crucial to ensure that the signals match the expected norms outlined in the service manual. If the test reveals that the circuit is indeed shorted to power, further action will need to be taken to isolate the issue, which may involve inspecting the wiring harnesses for additional faults. This thorough approach increases the chances of accurately pinpointing the malfunction. Once you have completed repairs associated with the DTC P26E6, it is essential to perform a final verification to confirm that the issue has been resolved. Begin by clearing the DTC using the HDS diagnostic tool, which will erase any stored trouble codes in the PCM. Following this, a test drive of the vehicle is paramount to evaluate its performance under normal operating conditions. During this test drive, keep an eye out for any signs or symptoms that might indicate the problem is persisting. If the DTC reappears after clearing, this signals that additional investigation or further repairs may be necessary. Ensuring that the vehicle operates smoothly without incident solidifies that the initial fault has been adequately addressed. Preventive maintenance is crucial in ensuring the longevity and reliability of the starting system and avoiding issues like DTC P26E6 from occurring in the first place. Regular inspection of the wiring and connectors associated with the starter cut relay can help to identify any signs of wear, corrosion, or potential damage before they lead to significant problems. Keeping the connectors clean and ensuring a snug fit can prevent poor electrical contacts that may arise over time. Additionally, monitoring overall vehicle performance and electrical behavior can help catch discrepancies early on, which allows for swift interventions before they escalate into more serious faults. In short, proactive maintenance is a vital pillar in vehicle care. In summary, addressing DTC P26E6 requires an understanding of the starter cut relay's fundamental role and its interactions with the PCM. Identifying high voltage issues and following a systematic troubleshooting approach ensures that the root cause of the problem is effectively addressed. Conducting thorough inspections of electrical connections and wiring is essential, as they form the backbone of the starting system. After repairs are conducted, clearing the DTC and verifying operational correctness through a comprehensive test drive underscores the importance of ensuring that the issue is truly resolved. By applying these outlined steps and practices, you can maintain the integrity and reliability of your Honda Accord starting system, promoting long-term vehicle performance. Please like and subscribe to the channel. See you next time.